In this talk, I will describe our recent results in the search for the earliest history of the famous shell microstructure, mother of pearl. This shell microstructure is widespread within the mollusca, occurring in cephalopods, monoplacophorans, gastropods, and many bivalves as well, and so was thought to be a primitive in the mollusca. Okay? Now, first, before we get into that particular hypothesis, what is nacre? Nacre is a type of shell microstructure that consists of originated tablets, which you can see here, which are merged together into flat laminae. And the shape of the tablets varies pretty dramatically, but typically the tablets are roughly equidimensional. And this is an exclusively originated type of shell microstructure. And in addition to this, nacre is often characterized as a brick and mortar type of shell microstructure in that you've got alternating layers of mineral and organic matrices. And in addition to this, you've got a lot of organic material around the margins of each of the tablets. And this is one of the reasons why nacre is the most energetically expensive type of shell microstructure for mollusks to form. And it's also what gives nacre its great strength. And numerous studies have demonstrated, beginning with this one here and subsequent ones as well, numerous studies have demonstrated that nacre is the toughest, the most fracture-resistant type of shell microstructure of those that have been tested. And if you look at the distribution of shell microstructures in the Cambrian, you can see that there's a lot of data, and this data comes almost exclusively from steinkerns, phosphatic steinkerns, where you have the imprints of the type of shell microstructure preserved within the fine-grained phosphate. You can see there's a lot of data here, but no nacre. So this led us to conclude that nacre was in fact not primitive, but in fact it must have evolved independently within different groups of mollusks. And this is consistent with other recent studies which show fine-scale differences in both the structure as well as the composition of nacre within the different groups of mollusks that have it. So everything was coming together. It seemed to be pointing in the same direction. So our particular research involves a couple of different things. Number one, trying to fill out the pattern of shell microstructure evolution within the mollusks, and then in particular to try to figure out when nacre originated and in which particular groups of mollusks it originated within. And so more recently than the Middle Cambrian, the most promising localities that we have are unfortunately from the late Ordovician. Okay, so you don't have the right type of preservation, at least as far as we've been able to find, in anything between the late Cambrian through late Ordovician. But there are a couple of late Ordovician deposits which are quite promising. Number one, the Macquocata Formation that has nice cephalopods with shell material that gleams very similarly to nacre. So it has the same sort of pearly luster. And in addition to this, Harry Mutve previously described a very strange texture within these shells that looks a lot like nacre. He interpreted it as such. And in addition to this, we also looked at the Arnhem Formation from various places in the Midwestern US, Ohio, Indiana, and Kentucky in particular. Okay? Because this has the similar type of preservation to what you see in the early and middle Cambrian. Okay? So I'll describe some fossils from each of these and how they potentially show nacre. So the first one, let's start with the Macquocata, where you've got these beautiful specimens that seem to shine with something like mother of pearl. Now what this shows here, this is some stacks of tablets that are very similar to what Mutve described here. So you've got roughly equidimensional tablets here, but there are some things that are unusual. So you can certainly find nacre tablets that in modern mollusks that look a lot like this with this sort of subcircular type of outline. But what you don't see in modern mollusks are nacre tablets that are this large. So these things get up to about 50 microns in diameter, way larger than anything you see in modern mollusks. In addition to this, so you see this ultrastructure within the tablet that consists of these elongate elements. Sure, nacre has this, but it never has it in this particular radiating pattern. In fact, this looks awfully diagenetic, right, when you look at something like that. So there are some things that are very unusual about this type of preservation. When you look at this type of structure in side view, so you're looking at a vertical section here, you can see the flat horizontal laminae, and you can also see these vertical pore channels, which is exactly what you see in modern mollusks that have nacre as well. So vertical pore channels, you've got these flat horizontal lamellae. The spacing between these pore channels, in this case, is a lot more similar to what you typically see within modern mollusks. But you also see some unusual things. For one, you see a really large spacing between the individual laminae. So it doesn't look like this is replicating the original nacre tablet. And so these sorts of observations here, including the large size of these tablets, in addition to the radiating ultrastructure, in addition to a radiation of this particular pore channel filling, which in all of these cases has been shown to be calcium phosphate. So this is entirely calcium phosphate, entirely replaced, led us to this particular hypothesis for the preservation of nacre. So you have original oragenitic material in yellow here. This is dissolved away. You've got the organic membranes and the pore channels remaining behind. And these serve sort of as a conduit for phosphate precipitation. So the phosphate comes in down these pore channels and then spreads out laterally and meets its neighbors over here. So the structure of this overall looks very similar to nacre. Looks like the evidence suggests this is in fact nacre. But in addition to this, so Mutve was right. So in addition to this, though we also have found some other areas within the fossil that show imprints of the tablets themselves. So this presumably is showing what the tablets look like, not that very strange radiating large disc-like structure. So these are imprints on in this case, it would be a little bit of an internal mold of the shell itself. In order to figure out what the shell originally looked like in this particular case, the microstructure, you can electronically invert that image. And so in all subsequent images where you see inverted, that's what I've done, electronically inverted it. So you can see the tablets very nicely preserved right here, arranged in flat laminae. Here's a lamina, here's the next lamina. There are other ones over here where you can see the building on from that. And this particular shape of nacre is something that's seen very often in many different kinds of mollusks. The diameter of these particular nacre tablets is consistent with what you find in modern mollusks as well. So this provides maybe even better evidence that, in fact, you've got nacre here in the cephalopods, at least some groups of cephalopods, from the late Ordovician. And perhaps this is not surprising because nacre is particularly widespread amongst fossil cephalopods. So it seems likely that that's probably primitive, at least in that group. Okay? So another thing you can do with these tablets is you can measure the interfacial angles and try to test whether, in fact, they're consistent with nacre or the other reasonable choice for what this microstructure might be, calcitic semi-nacre, which also contains roughly equidimensional tablets, but the composition, single crystals of calcite instead of a composite type of thing with aragonite. And so in that particular case here, you can see the angles match very nicely nacre, much better than they do calcitic semi-nacre. So this appears to be nacre here. All right, good match. So you've got it in the cephalopods in the late Ordovician. What else? So if you switch a little bit, switch to another part of the Midwestern United States, to Ohio, Kentucky, Indiana, you can see in the Arnheim Formation, you can see a very nice preserved nacre within some of these bivalves. So here you've got an imprint of the tablet here. So this is not an inverted image. So the tablet would have been here. You also see the tablets coming together in nice lamellae. You can see a little bit of the preservation of the overlying organic matrix here as well. And so what's interesting here is not only do you see something that looks a lot like nacre, but it looks a lot like bivalve nacre in that the individual tablets are offset a little bit in each subsequent layer. Okay, so very similar sort of thing. And of course, you can measure the interfacial angles of these guys. When you do that, here's what you get in that particular well-preserved tablet, the best preserved tablet on that specimen. Boom, falls in here with what you expect from Nacre. Okay? Now, other specimens show other kinds of, this is also a bivalve, other kinds of Nacre-type tablets. In this case, a little more oval. And you can see, again, different lamellae, nicely preserved. Here's some incipient tablets here. So this also adds to the support for the hypothesis that you've got Nacre in this late Ordovician bivalve. Now, the muscle scars are incredibly nicely preserved on this specimen. It's probably the best I've seen so far from the Cambrian Ordovician. So you can see something here very similar to what you see in the muscle scars of modern abalone that don't have the typical pattern of prismatic microstructure in the muscle scar, but instead have a step-like sort of preservation, a step-like form, which you can see very nicely here. So all this is consistent with Nacre in these bivalves. So you got Nacre in cephalopods, Nacre in bivalves from the late Ordovician. What else? Let's keep looking. Well, there's some evidence for Nacre in gastropods also from the Arnhem Formation, in this case of Ohio. This particular type of morphology is very similar to a vettigastropod you see here, Haliotis, abalone. So very, very similar form. But unfortunately, this is the only sort of specimen where I've seen this type of preservation. And so in addition to this, where it occurs on the internal mold is a little bit unusual. So because of that, I think it's not enough evidence to say with certainty. So question mark for the gastropods. Now, of course, why constrain ourselves to the Ordovician? There could, of course, been Nacre in the Cambrian. So why not keep looking? One very nice specimen to look at is Macononia. Macononia has beautiful preservation in these regions over here where the internal mold sort of bulges out of prismatic shell microstructure. So there should be some sort of preservation in this region here in the troughs of the internal mold showing the inner shell microstructure. Maybe that's Nacre. So you can see here some imprints of tablets, very nicely organized. Looks maybe a little bit like the diamond-shaped structure I showed you earlier from the cephalopod. But if you measure the angle here, in this case, 7 different measurements on that particular image, bam, right there with calcitic semi-Nacre. Look at this specimen over here, beautiful tablets around. This is probably the best tablet I've seen in Macononia. Boom, calcitic semi-Nacre, calcitic semi-Nacre. So this is not Nacre here in the early Cambrian, it's calcitic semi-Nacre. And this is actually, this is similar to what you see in the similar morphological forms, similar stenothekids, such as melopegma, that have an outer shell microstructure, prismatic, inner shell microstructure, calcitic semi-Nacre, which you see very nicely preserved right here. So similar morphologically in that they both have lateral compression. They both have an undulating inner surface. They both have this shelf here subapically. So this adds support to the hypothesis that we presented earlier that there's a strong phylogenetic signal to shell microstructure data in the early mollusks. So similar shaped forms have similar types of shell microstructure. So no Nacre until sometime between the late Cambrian and the late Ordovician is when Nacre presumably originated. That's our best guess based on the available data. And this fits in with this step-like increase in predator-prey escalation. And you can add to this Alexander Nutzel's descriptions of the independent origin of planktotrophy within mollusks as well between the Cambrian and Ordovician. So it appears similarly, you've got Nacre originating here independently sometime between the Cambrian and Ordovician. And this is reflecting the increased predatory pressure at that particular time. So to sum up, you've got calcitic semi-Nacre, not Nacre, in the Cambrian Halcyon Macononia. This is similar to what you see in morphologically similar forms, stenothekids, so that strengthens this hypothesis that you have a strong phylogenetic signal for shell microstructure. Earliest Nacre that we know of Currently, from the late Ordovician, we see it in some bivalves, some cephalopods, possibly a gastropod, jury's out. And the parallel origin of Nacre reflects this increasing arms race during the Great Ordovician biodiversification event, or possibly just prior to that. Thank you.